Nobel laureate David Gross once said, "It's a crisis, not a quarrel or issue." There haven't been any new galaxies or discoveries since the summer of 2022. The predicament facing researchers around the world is unprecedented. The most recent discovery made by James Webb has the potential to completely alter the science of cosmology. The Nobel Prize-winning theoretical physicist David Gross summarizes it as follows. Science is not experiencing a scientific problem here, but a tangible crisis that will overturn everything. Why are our scientists acting so strangely? There has been anarchy ever since James Webb first showed the early universe. Scientists may have misrepresented half-truths as unquestionable facts, which has left them in despair. Now, dozens of possibilities are being tested. Do we now have to confront the uncomfortable reality of spending nearly a century believing a wrong doctrine? Did the universe have no beginning? Billions of school textbooks worldwide may soon need to be revised if the Big Bang theory is proven to be incorrect. Not only will the Big Bang itself be impacted, but this fundamental theory may also cause other physical ideas to abruptly become outdated. Then, a completely new physics would be beginning. The crisis's inception. Let's review the events that have transpired since the summer of 2022. In July 2022, the new groundbreaking space telescope James Webb produced the first deep image of the cosmos. The earliest galaxies whose light Webb can detect are shown here. The oldest light sources are the reddish and orange light patches. A Harvard researcher named Rohan Naidu revealed an amazing discovery a few days after the photograph was released, a galaxy with a redshift of 13Z, which indicates that the galaxy existed 200–300 million years prior to the Big Bang. The old formula is no longer valid because we now know that galaxies form over billions of years. The second surprise is that during what scientists have dubbed the Dark Ages, when there were only a few early stars, these galaxies were not only exceptionally developed, but they were already glowing. As of right now, about 20 of these very old galaxies have been confirmed, and dozens more may follow. Additionally, at least 7 black holes that were too big to be juvenile black holes and appeared too soon after the Big Bang were discovered by researchers. The largest issue in contemporary cosmology was brought on by this, and there are still no solutions. Questions are being raised concerning the Big Bang itself, the theory of the universe expanding, the origin of the earliest stuff in space, redshift measurements, and a host of other topics. Does the Hubble constant have an error? It may surprise you to learn that practically every theory on the Big Bang is predicated on a single observation that may now prove to be incorrect. In the 1920s, Edwin Hubble made the discovery that galaxies travel at a speed proportionate to their distance from us. This impact was precisely characterized by his formula, V equals h0d, which led to the creation of the Hubble constant and, later, the notion of an expanding universe. The Big Bang theory was just a few steps away from the Belgian physicist Georges Lemaitre's theory that the universe began at a single place. Thus, the universe's expansion rate indicates the speed at which galaxies are separating from one another. Hubble's findings were subsequently verified on numerous occasions. The discovery of cosmic microwave background radiation, which likewise exhibits distinct patterns of expansion, provided new evidence. Investigating the universe's large-scale structure has become increasingly possible because of modern techniques like baryonic acoustic oscillations. And that's where the first serious issues started. According to more recent measurements, the predicted Hubble constant varied slightly but significantly depending on the object or method utilized. Additional disparities surfaced, which are referred to as the Hubble tension. Although there have been no successful attempts to alleviate Hubble's stress, James Webb's most recent findings may offer crucial hints. It is not surprising that measurements of the biggest structures in the cosmos exhibit glaring discrepancies if our outdated assumptions are fundamentally incorrect. Is there no such thing as dark matter? It's intriguing since issues with the conventional cosmological model surfaced early on. The movement of the stars in the outer regions did not fit the known physical dynamics in the interior, as Swiss astronomer Fritz Zwicky discovered when he examined the odd movements within galaxies. There has to be some unknown force at play here. This is where the concept of dark matter originated. Dark matter has since been incorporated into the picture that cosmologists and astronomers have been constructing about the origin, evolution, and operation of the universe. However, it was still an untested idea. There is currently no proof that it exists. Because dark matter served as a sort of glue that attracted and held together normal matter, it is believed to have been crucial for the development of the first galaxies. The concept envisioned the earliest gas and dust clusters to form dark matter halos. More and more ordinary matter was drawn into these halos' sphere of influence by their gravitational pull. Stars and finally galaxies were formed when the normal matter within these dark matter halos further condensed and collapsed under its own gravity. Normal matter could not have accumulated to high enough densities to create stars and galaxies if dark matter hadn't been gravitationally sticky. On a broader scale, dark matter is believed to be distributed in a cosmic web, with dark matter halos serving as significant nodes. Clusters and superclusters, which are large groups of galaxies, can be explained by this. The universe's large-scale structure is also determined by this network. However, a growing number of disparities are currently being caused by observations of the universe's large-scale features. It appears that the cosmos is constantly attempting to tell us that there is a problem with the outdated computations and theories. Goodbye, dark energy too? What if dark energy was a myth as well? It was cited as the primary cause of the universe's fast expansion. When compared to the Big Bang theory, measurements revealed that the universe had been expanding more quickly for 5 billion years, which at first seemed illogical. Evidence for the presence of dark energy was discovered in the cosmic microwave background radiation and supernova data, in addition to the universe's accelerating expansion. To put it briefly, dark energy accelerates the universe and pushes it apart through its repulsive impact, whereas dark matter uses gravity to hold galaxies together. However, there is also no proof that dark energy exists. Even cosmological ideas that do not require dark matter or dark energy can describe the universe in the same general terms. This is accomplished, for instance, by altering a few cosmic constants, as the MOND hypothesis envisions. Even if MOND can't explain the entire universe, it can explain so many parts of it that other theories need to be considered. Theories that were previously given less consideration are now receiving more attention when James Webb demonstrated that the conventional wisdom was incorrect. What if, like the Big Bang, dark matter and dark energy abruptly vanished from physics? What would happen next? We don't yet know which old hypotheses will become popular and which new ones will emerge in the next months. Right now, time is totally up in the air, finding the large-scale structure behind the Pandora galaxy cluster. Once more, James Webb did it. Webb captured another deep image in the spring of 2023. The image displays the Pandora galaxy cluster this time. The gravitational lensing effect brings old galaxies and stars back into focus behind the cluster of galaxies. Scientists are already used to seeing really old galaxies that aren't really possible. However, this picture revealed something else. Behind the cluster, there seems to be a massive edifice. This formation is so massive that, if preliminary measurements are accurate, it might represent a galaxy cluster. The structure is too big and too old to have existed in a young cosmos, which is the main issue. The universe 13 or 13.5 billion years ago looked considerably different from what scientists had previously projected with their models and hypotheses, as demonstrated by this next piece of evidence. The researchers were given even more problems to tackle rather than fresh answers. We must hope that more and more pieces of the puzzle will gradually come to light, and we may soon hear of an increasing number of odd discoveries. Scientists won't even attempt to propose new theories until we have as much information as possible. The Webb mission is currently too early to draw any firm conclusions. One of the certain exceptions to this rule is Rentra Gupta, who lives in Ottawa, Canada. His extended cosmic cycle idea was well received by his scientific peers when he revealed it in 2023. Gupta demonstrated how an entirely new era of the universe is made feasible by combining ideas from the cyclical universe, modified gravitational theory, and dark energy. The cosmos was already mature and highly developed 13.5 billion years ago. This might be explained by the figure of 26.8 billion years, which would allow more space for the formation of galaxies and stars. James Webb receives support. To resolve this crisis, we require additional evidence. Even though James Webb's mission will require many more years, the cosmic issue is unlikely to be resolved by Webb alone. In 2023, ESA sent the Euclid Space Telescope into orbit. Making the universe's most flawless map is Euclid's mission. Researchers anticipate that it will offer more hints on the presence and operation of dark matter. Euclid can also be used to examine alternate theories for contemporary reasons. The Nancy Grace Roman Space Telescope will monitor cosmic expansion precisely and examine cosmic occurrences, including supernovae, starting in 2026. Another technological advantage in the competition is the Vera-C Rubin Observatory. Exact illumination of the universe's large-scale structure will be provided by the Earth-bound telescope. Scientists want to learn more about how clusters and superclusters originate, as well as the function of cosmic filaments. In particular, the Vera-C Rubin Observatory will look for gravitational lenses. These are essentially all very huge objects in the cosmos that, because of their gravity, function as magnifying glasses. The telescope will be situated atop northern Chile's 2,682-meter high LPN peak. ESA's SpaceX project will survey the entire sky in a wide range of hues in 2024, re-examining the universe's history. SpaceX may play a significant role in resolving the current cosmological problem by gathering information about cosmic backdrops.